Okay, yeah, I'm running a simulation on. You can see this circuit here, basically. I got this set up so that I could establish transient conditions. Right now, the thing's turned off. You don't need this anymore, really, because I zeroed the capacitor's voltage at startup. But anyway, if we go ahead and turn this on, we can kind of see how this oscillator builds up. Because right now, you can see that initially, so this is a 5-volt battery. So initially, our 5 volts comes into the terminal, but it drops down to like 0 volts here, like 500 millivolts, and then 500 millivolts or so here. So this is positive, these two are negative. This is negative because it's going basically through this diode here. So, and it's assuming still an initial current, which in reality it wouldn't have one. But but still, this is just the best I can do, trying to do a transient analysis. I want to see how these coil voltages change as this progresses. I got it set to, like, I don't know, what does it say, 10 nanoseconds, as far as its analysis period. So, good, I had to restart it because these capacitors were reading backwards, so I had to flip them over and then run it again. But so you can see the current's really low to begin with, okay, really low there, and again, it's assumed to be like a milliamp here. Okay, see, when I do that, it kind of, I make changes like that, it causes it to skip ahead a little bit. But at any rate, so now we're all of a sudden up to 6 milliamps, and you can see the voltage is changing a little bit. We've got the voltage of this coil over here, alright, and of this coil over here. So, so we can kind of see, how the voltages on these coils change, and this right here is the voltage on our load, which I have set pretty high. And this, well, this circuit right here is derived off of, this one out of that 200, Radio Shack user manual thing. So I think I use this as a basis while trying to understand this one. But at any rate, yeah, so this is, going to progress. I'm going to be stopping this recording a lot, but yeah, you can kind of, see what's going on. Right now we still got only 70 microvolts across these components. I really wish, I probably ought to just fix the scale on these, but because this looks more extreme than it is, but it's really only 70 microvolts. This capacitor still essentially got a short circuit, as is this one. But again, our current's picking up most of the current's going through this capacitor initially. I got this set like as low as it'll go simulation speed wise. I'm gonna let it run there and go take a leak. Whew, that's cold. Yeah, basically, yeah, I guess it probably hadn't changed much since I left. But yeah, I mean, you know, I don't know how accurate this thing really is. You know, I mean, I have a lot of, you know, reservations, but I'm hoping it's at least accurate enough in simulating some of this initial stuff. Because this is supposed to be an audio transformer, but, you know, I'm not really sure what the impedances are. I mean, I just set it to 40 millihenry, you know, I have no idea what the inductance would actually be. I know it's certainly not going to be as high as 4 Henry if they had it set at initially, I would imagine. But at any rate, yeah, so we're up to 70 microvolts. But so, alright, so let's jump this up to, so I may have to restart this thing because of crap like that. Let me do that. I should be able to. It was a pain in the ass to restart it because of those capacitors, but now that I'm starting from 0, you know, because you can see the voltage is increasing here, and then staying basically the same here. But what's happening is that, you know, as current picks up, you know, as current picks up through this transistor, it's increasing, you know, the field, you know, the current flowing through this coils and charging up the field, but that's generating a back EMF or counter EMF, which is showing up across this coil over here as an increasing voltage. So, and we can see, you know, that voltage starts at -5 volts or whatever, but now it's starting to rise, and this is going to rise eventually up to 5 volts. But you can see the current here is going to pick up as it starts to charge this capacitor, you know, and the voltage across these is going to increase, you know. You know, this one probably a little faster than this one. So we've got some current going through this resistor here, you know, in the form of 1 microamp. So, so this is the, you know, voltage right here. You know, so that's showing you what's going on with the collector right there. But you can see the current, you know, is really, you know, going through the roof down here. You know, it's really starting to pick up now. As it does, you know, the voltage is going to accelerate. You know, as that DIDT changes here. Part of the current's going there, most of the current's going through there, and that's charging up the field, and again, it's causing the voltage to rise here. Let's run this again just to see, because I mean, you have that little hiccup. Start at 12 milliamps. see this got 91 milliamps versus 92 milliamps flowing through it, but remember that current's flowing through this coil, so even though it's got 46 milliamps, it's actually coming from this field charging up that's actually supplying this current primarily. So, you know, because that's what I'm saying, there's very little difference here. You know, you get 91.3 versus 92.2. I mean, that's like a milliamp difference, but yet we've got 46 milliamps up here. Where's that coming from? Okay, well, it's coming from this coil right here. You know, again, we've got a building voltage here. So, you know, that's that's causing the thing to really supply current to charge this capacitor, but it's actually coming from the fact that this current, you know, its DIDT is really high right now, or not real well. Let's see, it's not really high right now. It's starting really low, but it's picking up speed. That's inducing a voltage into the second coil, which is actually supplying the current. So it's basically taking energy. This coil is taking energy from this coil, basically, which I assume is impeding the whole process of it charging up. But the point is that it's extracting energy, and, you know, in here, you know, we hardly have anything. You know, you can see this resistor has like microamps of current flowing through it right now. I mean, it's hardly anything on the load. So again, most of our field is being used, though, because this transformer has a 1-to-1 configuration. You know, if you look at it, see what I mean? So, you know, again, most of it, our charging field here is actually being used up over here on this at the moment. So, like I said, it will continue to increase, and this will continue decreasing, you know, as we progress along here. You know, our wire here at our base, you know, that current's, you know, skyrocketing, as you can see here. Got the COVID. Ugh. Let's see, you can tell these currents are still closely matched, yet the current continues to rise here, you know. And normally, if you look at a nodal analysis, that would be rather confusing. Well, let's see, we got a bunch of current coming in here, and, you know, yeah, most of it's coming in here, but only 1 milliamp or so is going that way, but no, it's 100 milliamps. Yeah, it's because of that coil stealing from the field. Okay, well, I guess that's, well, I still don't know if that was a glitch for me stopping it or not. You know, just trying to figure out where this curve is, this little glitch here is coming from. That's why I restarted it. Let's see, yeah, it's about 800 nanoseconds. Yeah, and it occurs about the same time. It's probably just an algorithm switching gears or something, I guess. In fact, let's reset it just to be sure. I can't change this. It'll fucking glitch it again. Well, I'll pause it while I see. Yeah, we're almost there. We're at 700 nanoseconds. I think this transistor has a beta of, okay, it has a beta of 100. But, you know, 2.3 milliamps, that's a lot of current to be going through that base already. So, but yeah. So the glitch is still there. This is probably just an artifact of the simulator, I would imagine. Yeah, about 800 nanoseconds, you know, it occurs here too, so it's some kind of a transient thing, and it's probably switching gears, I would imagine, changing its models, something. You can see, you know, we're still minus 3 volts here. Like I said, this will continue to increase. any rate, I'll pause it. Yeah, I'm about to go to positive voltage now. It's quite a bit of base current to be flowing through this thing. It's obviously not much current flowing through this resistor. Yeah, see, we're finally gone positive now, and we're up into the millivolts. See, as we do, you know, voltage is really starting to, you know, be impressed across these capacitors. So this has already got like 6 volts across it, because this voltage here is being added on top of this voltage here, so it's causing these capacitors to charge above the 5 volts of the battery. And you can see the current right here going to the base is actually starting to level off. I mean, it's actually on a diminishing trend. You know, whereas this is skyrocketing by comparison, and this is just holding steady right now at 5 volts. You know, the capacitors continue to both charge up, and even a resistor is starting to get more and more you know, current and voltage across it, across our load. Let's see, now these are about equal, so, you know, as you can see, we got approaching 10 volts across this. So I mean, this voltage is actually higher than this voltage now. You can see the current here is about to peak. So, and this represents the current, by and large anyway, going through this. It's 200, well, no, that's only 260 milliamps right there. I guess I was looking at the wrong goddamn thing then, huh? This is what I should be actually looking at the current from, not necessarily this, because this includes this capacitor charging current. Well, like I said, yeah, this is only 250. It's about the same current as we had here. So, in fact, that actually works out more logically. tell at this point anyway, our base current is falling off here. And that happens as our voltages continue to rise across these capacitors. In fact, you can tell that, you know, shit, we're already up to 17 volts, you know, from a 5-volt battery here. But, you know, the capacitor charging current is definitely falling off now. Resistor voltage is getting up there, and like I said, your base current's definitely on the decrease. It's headed down. Like I said, you know, this is still held steady all this time, but it looks like our voltage here is starting to level off, you know, as our base current begins to decrease. Yeah, but anyway, I guess my analysis from earlier, you know, where I was trying to figure out where this current was coming from, you know, was incorrect. I mean, it was actually, you know, not coming from this field. It was coming from just this capacitor charging up. So that's why this was higher, you know, almost as high as this, because technically it's actually getting all the current going through it. So, anyway, it looks like we're about to peak here on the voltage. Again, the total voltage is going on 20 volts. You know, you can see the you know, the base voltage here is, you know, 700 millivolts, but it's starting to fall. Here you can see the base current is actually, you know, almost zero now, and the collector voltage is dropping precipitously. Okay, now it's just gone into kind of an undefined state, you know, because we're down to almost no current and there's very little flowing here. Our voltage, you know, is peaked on the output, and this is as charged up as the capacitors are going to get. But again, now the simulator starts to, you know, not quite know what to do with it, I guess. But see, this is what I was looking at, trying to, because I wondered what happened, you know, when the current stops increasing, you know, which it pretty much has. I mean, we're down to just, you know, very small amount of current coming from a power supply and almost nothing going through the coil. So in theory, the fields are collapsing right now. That's what should be happening. And as those fields collapse, you know, they're trying to maintain the current, ostensibly, but obviously it's not showing that very well. And that's probably why this thing's so confused. It doesn't know how to handle what happens, you know, when that transition point occurs. But as this field collapses, it should definitely, you know, generate a voltage of opposite polarity. So, but that should be, you know, really taking our, you know, voltage below zero, which in fact is showing that over here, because as this voltage here reduces, remember this capacitor still got an 18 volts across it, so this is actually forcing this negative terminal down below ground, as this voltage, because this is what it's in reference to, as this voltage falls. See, this is, still confused about where it stands, but the whole while it will be causing this voltage to drop below the threshold of this transistor, turning it further off by actually making it a negative going signal, which actually could be a problem because a lot of transistors can only stand so much of a reverse voltage across the base emitter. So, I mean, I believe that's an actual rating in a data sheet. This reverse voltage withstand capability. But again, I don't know how accurate these voltages actually are, and I don't know how much they pertain to real life anyway, because again, I have no idea what the actual various parameters of like an audio transformer are, or if this even really accurately represents a transformer at all. But at any rate, right now we're in a bunch of hash, so I mean, we're not really seeing much. All this thing's confused. So gotta pick up the speed a little bit. See if anything happens, or if this thing's just gonna remain confused because of how, finally I'm running it. You can see the voltage is certainly trending down, in some of these areas. So you can see our capacitors are generally discharging. They're actually pretty clean, but like I said, this area here, it's hard to say what the fucking voltage actually is. But I just know this transistor is really, that's why you see such low currents here, it's really hard, in a hard off condition, while this field collapses, because it's still got a voltage on it. If this field had completely collapsed, this would be a negative voltage again. Theoretically, it should end up a negative voltage again, at some point. Just like it started with, you would expect it. Once the field is completely collapsed, there's nothing to provide a, electromotive force on here. But I was kind of wondering, as this collapses, okay, what's discharging these capacitors? I mean, in theory, it's probably the field, right? It's about 10 volts across this. So in theory, this collapsing field is maybe trying to draw those capacitors down too. But it's still certainly keeping the transistor hard off, and that's like nanoamps of current right there. So, we have picoamps of current going through the base too at this point, which is weird. I mean, okay, how is this capacitor discharging? Although it could be discharging through this resistor, actually. Yeah, in fact, it probably is. That's probably discharging this capacitor anyway. This capacitor, you can see, is starting to do something interesting. Yeah, because the hash is all disappeared now, so that's good. It's figured out where it is now. Okay. But see, now we're starting to get positive current again, so, the transistor is actually starting to conduct. So, but this still has not dropped down to 0 or nothing. Yeah, I guess it's still trending downward. Not at a very high rate. And like I said, our voltage here must be on the rise again. increasing, which is causing this current to increase again. But, you know, and our, you know, voltage here continues to fall. So unless current continues to rise, I kind of expect it to be in reverse almost. So this is already trending positive. The current was negative, so I guess it's finished discharging now, and that's starting to increase. Now it's hiccuping again. And down here, you know, gets hit the knee or whatever, causing it to switch on. I mean, that could be the transistor's knee right there that it's causing that deflection, that diode knee. Let's see, this has gone positive again, and now is increasing. So that never actually went negative or anything, interestingly enough. So but that's because our current here is increasing again, and so I'm still confused. Oh shit. That's what I was looking for. So this voltage has finally dropped negative. And that's what I was seeing before in simulations, you know. So this voltage here and this voltage here are both negative now for some reason. You know, in theory, that's a response to the field collapsing. And why we didn't see that earlier, and whatever the hell is going on, I don't know. Imagine this thing is not very good at handling this, would be my guess. Because, you know, that's what I expected. I expected once this transistor is off, this field should collapse, and as it does, it reverses the voltage across this, you know, these coils. You know, thus sending, sending this voltage negative, which in fact is what happened. I mean, that voltage is well below ground now, and it's because this capacitor voltage, you know, is above ground but being forced low because this is actually low because it's got these reverse voltages across it. So, you know, because again, this is like 5 volts, you know, opposing this, because that's our positive 5 volts, but it's like we got a battery's negative terminal tied here and its positive terminal here, you know, counteracting the voltage on this battery. So it's and then some, you know. But again, the field basically should be collapsing in these two, so, you know, but we've still got a total of like, you know, 10 volts across it. But you can still see, you know, like 11 volts here, You know, but this capacitor here is already practically discharged. But like I said, because of how capricious this thing is, I just still can't get a clear idea of what the fuck this thing is doing exactly. There's just too much shit going on here for me to kind of keep track of. I mean, it's just baffling. I just don't know. I just can't visualize it. Because that's what I'm trying to figure out is, okay, you know, like with respect to this, what is this terminal's voltage exactly? Definitely headed towards a positive way now, and now our transistor is switched back on. Okay, that's caused our voltages to swing back positive, and actually pretty rapidly. You know, our capacitors are charged up to 20 volts now, and our shit's all confused again. Because, you know, the point is that, you know, this will only change, you know, as the current changes. So if the current's not changing, well then, you know, there's no field being generated, and it's that, I think this is where this hash is coming from. It can't quite, it's confused about, you know, that voltage this is generating versus this inclination to want to fall, so they just didn't simulate that very well. I mean, that's just not a case. I think that's where all this hash is coming from. I doubt that it would do you any good to you know, lower the resolution. Said, the moment its field starts, you know, once it peaks, you know, then it's sort of confused about what to do. It's just, you get this hash out of it. So this were a real device, I would say, well, that was probably some sort of, you know, like thermal noise or something you're picking up that's being amplified. But, you know, again, this is a computer simulation. It shouldn't have weird shit like that going on. So, like I said, you know, we can see the capacitors are discharging, and, you know, but we got this indeterminate voltage across it, but you can see it's generally positive here, and who knows down here. I'm not really quite sure. I guess, yeah, I'm not sure where the light is. This the baseline? I don't know. I guess so though. Certain it's trying to converge to something, and now it's, you know, pretty sure what it's doing again. So, oh, okay. Alright, so now we see what's going on at the base. You know, it's all of a sudden in the process of turning back on. Start to rise again. But again, I still think this is all part of its transient response. It's trying to figure out what the fuck it's doing. Certain. Okay, you can see. Plunging down to nothing. In fact, it's trying to go negative or whatever. But our voltages are really falling now across the coils, as you can see. So now our current through the capacitor is like going through the roof. So is it up here. So now the voltage here is increasing again as our current goes, you know, starts to increase. We go, you know, down to negative, so it's discharging now. Leaving it in a real uncertain state as these discharge, and it's just trying to figure out the shit's going on. I mean, because like I said, generally this should be forced below, but you know, it's still like a couple hundred millivolts, so the transistor is certainly hard off. But because of this voltage here versus this voltage here, you know, you'd think, I don't know. Like I said, now we're on the decline again. The transistor is switched off. This voltage has gone negative overall, although it's still hashed up, so it's hard to tell. This is about to crash here. Now you can see this is definitely gone negative. This is starting to. You can see these have both gone actually negative now, so volt range, which again suggests a collapsing field, because you're not going to get that from this. You know, our battery is not going to generate a negative thing, because I mean, it can't. But, you know, there's hardly any current flowing through here at all. So, you know, what's happening, where's this 10 milliamps coming from? Well, it's coming from this field collapsing. But the thing is, on this fucking program, they don't really show you the direction of current, if you haven't noticed. I mean, you know, technically this probably should have a, you know, a negative sign on it, because technically it's being discharged. So, you know, at least I believe it is. You can see this capacitor's got a negative voltage across it, so it's, you know, something's happening to it, you know, but this current should be opposite in sign. So again, that's why some of this shit, it just serves to confuse you. There's too much going on here to keep track of all the fucking errors in this stupid thing. I just want to sit here for a week trying to fuck with it. But it's because of shit like this that it's really hard for me to ever get a grasp of how this shit works, because of crap like this. You know, 'cause I have no idea how accurate this thing really is. So, I mean, at the end of the day, you know, it's about the best you can do. But yeah, I'm not really totally sure that it matters, you know. See if it ever goes positive again. Well, like I said, the waveform's anything but a sine wave, you know, at least if you slow it down. I don't know, I guess it's just going to sit there in an indeterminate state forever. See, we're still only in the, you know, like the microsecond range here. We haven't even gone a millisecond yet. Okay, looks like something's happening here. This capacitor's current has become positive now. It's still negative here, that's still discharging. Like I said, it is disconcerting how these keep changing scale. It also makes it hard to kind of keep track of it, you know, but unless you know what the voltage is going to be. I think that's part of the reason it's so hard to track this too. Yeah, okay, it's finally gone positive again. Alright, so same damn level on everything. seconds. So apparently, you know, something's going on that's wrong. This almost to insane levels. Well, anyway, yeah, I don't know. Baffling. Go back to the default. Okay. Well, whatever. Piece of shit. Text volume, idiot. Okay. Anyway, I'm done. Okay, I just had the fucking simulation turned down to 0 for some reason. Anyway, yeah, you can start to see. I got to set back to 5 microseconds. I think. No, I got to set to 1 microsecond. But at any rate, the point is that you know, you can kind of see what's going on. It's about a 2.8 kilohertz signal according to this, but I don't know exactly what's going on with these current spikes here, but you know, it's not too large really. That radically changes the frequency down to 600 hertz if I take that out of the equation, but it's still oscillating for some reason. I mean, I don't know if it's becoming resonant with this, because I mean, technically this is a tank circuit, so you know, you'd think these things would oscillate without anything, honestly. That's the thing, you can't scale the current versus the voltage, so this looks like there's like huge current flowing through, but there really isn't. 31 volts on this. So I don't know.